This is your instructional video over your STAR review. We will be looking at linear and quadratic functions. Please copy down the objective underneath the title of your booklet. The objective for this section is to review all the various characteristics that we've learned about a linear and quadratic function. Let's begin. Turn in your booklet to page 1. We will begin to define what a linear function is. When you first stepped into your Algebra 1 class, you probably began with something called a linear function. A linear function is a line that has an independent value and a dependent value. So remember, we talked about an independent value. And remember, an independent value is which axis, x or y? That's right, it's your x-axis or your x values. And it has a dependent value. Do you remember what axis that is? That's right, it's the y-axis. So a linear function is a line that has an independent and a dependent value. So let's ask the question, how do you make a linear function? Remember, you looked at an equation, y equals mx plus b, where we knew several things. M is called the slope. This is how steep your line was. And you had the letter b. This is called the y-intercept. This was a point of where it crosses the y-axis. So remember, this is a point, and it's going to cross the y-axis. So now we've defined what a linear function is. So let's look at part 1, finding the slope. So step 1, to any linear function, you have to find the slope. Do you remember what slope means? That's right. It is how steep a line is. So it's the steepness of a straight line. So do you remember, how do you find the slope? That's right, you use a formula. So the formula we're going to be using, and it will also be on your formula chart, y2 minus y1 all over, that's a fraction bar, x2 minus x1. So let's look at two different examples and let's find the slope in these two examples. So in example 1, I have a linear function. It's a straight line. So now I need to find the slope. So let's first pick two easy points that I can find the location. So this point right here is pretty easy. This location is 2, 0. Let's find another easy point. Let's look at this one. This point right here is also very easy. This point is 0, -3. Alright, so let's talk about how you find the slope. So the first thing I'm going to do is I'm going to make a t-table. Remember your x and your y, and I'm going to use the first point, 2, 0, and I'm going to list them first. Then I'll list the second one, 0, -3. Feel free to switch these two around. It still works. Now to find the slope, remember during the first semester we would move this sideways and it would become now y over x, and then now you would subtract the y values. So remember, we tipped it over, and now you have y2 minus y1, which is 0 minus -3. Careful here, what does that become? As well as you have x2 minus x1, which is 2 minus 0. So now you just have to do the math. Remember, a negative and a minus becomes a positive. So this is 0 plus 3, so it's going to be 3 over 2. So your slope is positive 3 over 2. And that makes sense. If I were to put my pencil here at this bottom dot, I would go up 3 lines and to the right 2. So that's my slope. Can you find the slope in example 2? Hit pause, hit play to check your work. the first hint I'm going to ask you to look at is you can pick any 2 points since I gave you a table of values. You can pick any 2 points. What I would like you to do is pick these 2 points and try to find the slope with these 2 values. Alright, with the 2 values that I chose for you, and again, you could use any 2 points, it would work the same if you did your math correct. The first thing I did is I went ahead and rewrote the XY table with these 2 particular points. Now, do you remember what you do? That's right, you're now going to turn this table sideways and you're going to subtract the 2 numbers. So 2 minus 8 over negative 2 minus 1. Now, all you have to do is either put it in your calculator or do the math. So you would get negative 6 over negative 3. To reduce this, remember negative and a negative make a positive, so it would be either 2 or 2 over 1. That's your slope. This is your instructional video over your STAR review, linear and quadratic functions. We will be looking specifically today at page 2. Remember, the objective is to review the various characteristics of a linear and quadratic function. Please turn to page 2 in your booklet. Today on page 2, we will be looking specifically at how do you write an equation of a line. So do you remember what are the steps in knowing how to write an equation of a line? Well, let's think about what step 1 might be. Well, we already looked at step 1 in the previous instructional video. Step 1 is you need to find slope. So if you forgot, please go back and revisit page 1 in your booklet. And please feel free to watch that instructional video if you have forgotten how to find slope. Step 2, you're going to need to find a point on the line. And it doesn't matter which point. I would pick an easy point to use. So you want to pick a point on the linear function. Step 3, what you're going to use is you're going to use the formula y minus y1 equals m parentheses x minus x1. And we'll talk about what all this means in just a second. And then step 4, you're going to use your Algebra 1 skills to solve for y so that you can find the actual equation. So let's follow these 4 steps with the 2 examples that we have. So here on the left, do you remember the first step that we did was we found slope. Please look back at page 1 to see what we got on this example here. From page 1, the slope that we found in this example was 3 over 2. So step 1, we found the slope. Step 2, we want to pick a point. Now, the point I'm going to use is one of the easier ones. It's going to be 2, 0. Now, you can feel free to pick another point. You can use 0, negative 3 if you would like as well. Now, step 3, I'm going to use the formula y minus y1 equals m parentheses x minus x1. So you're probably asking yourself, well, where is this y1 and your x1 coming from? Well, this is your point. So this is why you pick a point. Your point here is your x, y value, which we actually found is 2 and 0. So remember, which one is the x value, which one's the y value? That's right, 2 is your x value, 0 is your y value. So what you're going to do is you're going to replace them, and it's called substituting. So you're going to leave the first y alone, minus, and this is where you have your y value, which is 0. Equals, and then m is your slope. So then we found 3 over 2 is your slope. Parentheses, you're going to leave the x alone, minus, and now you're going to look at your x value from the point that you picked, which is 2. And now this was step 3. For step 4, now you're going to use your Algebra 1 skills and you're going to solve for y. So the first thing I'm going to do is leave the left side alone and I'm going to distribute the 3 halves. So I'll keep the 3/2 x, and I'll be your calculator for you. 3/2 times -2 is -3. Now you're almost done. Which two numbers do not have letters with them? That's right, 0 and -3. So what you're going to do now is move the 0 over because I want y by itself. So I'm going to add 0 to both sides. Since 0 does not have a x, I can't put it underneath this. I have to put it underneath the -3. So then now, all I'm going to do is bring down the y, bring down the equals, bring down my slope, and then -3 plus 0 is -3. So congratulations, this is how you write an equation of a line. Can you try example 2 on your own? So what do you need for step 1? That's right. Go back to page 1 and find the slope that we found. 2, you're going to need to pick a point. I'm going to pick a point for you. Let's use -2, 2. Step 3, you're going to need to use the formula y minus y1 equals m times x minus x1. And step 4, you're going to use your Algebra 1 skills. Hit pause at this time, hit play to check your work. From example or page 1, we found that the slope is 2. The point that we chose is -2, 2. Now you're ready to substitute. So remember, -2 is your x value, +2 is your y value. So now you're going to replace y minus the y value, which is 2, equals your slope of +2 times x minus, now be careful, this is x minus a -2. So what does that make this sign? That's right, it becomes a +2. Now step 4, you're ready to use your Algebra 1 skills to find y by itself. So you're going to copy the left side down. You're going to distribute, so you get 2x. Careful, this is 2 times +2, which is 4. Now, what two numbers don't have letters with them? That's right. So you're going to move the -2 over. So then now you have the final answer of your equation. Y equals 2x plus 6. Congratulations, you now know how to write an equation of a line. This is your instructional video over your STAR review, linear and quadratic functions. We will be continuing in your booklet, page 3. Remember, the objective is to review the various characteristics of linear and quadratic functions. Please review page 1 and 2, and we will begin at page 3. Here on page 3, we will be looking at graphing an equation of a line from an equation. So now we're ready to go backwards. We're going to give you an equation of a line. Can you draw the linear equation or the graph? So what are the steps? Well, the first step you need to do is make sure it is in standard form. So we're going to check for standard form. Remember, that means your x and y's are all on the left side. So it might look something like this. -2x minus 3y equals 6. That is called standard form. Step 2, we're going to use your Algebra 1 skills, and then you're going to solve for y. So you're going to move all this stuff so that it's going to be y equals, and then all this other stuff. Well, all this other stuff is actually going to look like y equals mx plus b. That's why we're going to use our Algebra 1 skills. So that you can, step 3, you can start graphing it. So this first thing you're going to look for is you're going to graph the y-intercept. So that means where it crosses the y-axis. So this is going to be along the y-axis. In step 4, you're going to graph the second point by using, so you're going to graph using the slope to make the second point. Okay? All right, so let's try example 1. All right, so in example 1, let's first see if it's in standard form. It is. Check. Now step 2, we're going to change this so that y is by itself. So that means I'm going to have to get rid of this negative 6x. And how do you do that? That's right, you're going to add 6x to both sides. Now, can't put it underneath the y, can't put it underneath the 8 because it doesn't have an x. So I'm going to put it out to the side. Alright, so now I'm left with 2y, and now I like to put my x's first. So I'm going to put 6x plus 8. You're almost done. So how do you get rid of this 2? Because I want y by itself. That's right. You're going to divide everything by 2. Everything. What you do to one side, you do it to all. So now you're left with y equals 3x plus 4. And this is the equation that you can graph now. Alright, so do you remember the 3 represents what? That's right, the 3 is your slope. That means your m value. So do you remember what 4 is? That's right. 4 is your y-intercept. This is your b value. So this is where I'm going to start my dot at 0, 4. So I'm going to go up to my graph. Here's my x-axis. Here's my y-axis. Since I'm at 0, 4, I'm going to go up 4 lines. 1, 2, 3, 4, and put my first dot. I'm done with step 3. Now with step 4, I'm going to use the slope and I'm going to count. Now 3 is not a fraction, but how can you make 3 into a fraction? That's right, it could be 3 over 1. Since this is positive, I'm going to take my pencil, go up 3 lines, 1, 2, 3, and to the right 1. Now you can do this one more time if you would like, or you have enough dots. 2 dots is enough to make a line. Take your ID and connect the dots. Alright, so since this is a linear function, remember you can't just stop after you connect the 3 dots. This is an actual line. So the line needs to be as long as the graph, and then don't forget to put the arrows at the ends, which means it keeps going on forever and ever. Alright, so let's see if you can try example 2 on your own. Remember, the first thing we want to do is to check to see if it is in standard form. And it is. Alright, at this time, hit pause. Try to get this so that y is by itself. Hit play to check your work. Alright, so the first step you should have done is subtracted 4x from both sides. Now remember, the 3 and the 12 do not have x's, so you cannot put 4 negative underneath that. So this is what you would get. 3y equals negative 4x plus 12. So now the last step is to divide everything by 3. So then now your equation is y equals negative 4/3 x plus 4. Now, do you remember how do you graph this? Where is the slope and where's the y-intercept? Is this what you came out with? The slope is negative 4/3 and the y-intercept is 0, 4. So let's go ahead and graph it. The first thing I'm going to do is label my x-axis and my y-axis, and now I'm going to put a dot at 0, 4. So remember, you're going to go up 4 lines and then put your first initial dot. Now since your slope is a negative 4/3, I'm going to go down 4 lines this time, and then to the right 3 lines. So then now you can tell that my line is actually going down. It's decreasing because my slope is negative. So now you're going to take your ID and you're going to connect through all 3 dots. Don't forget, your line has to go through the entire graph because this is a linear function. It doesn't just stop after touching these 3 dots. So your line looks like that. Congratulations, you now know how to graph a line given an equation. This is your instructional video over your STAR review, linear and quadratic functions. Today we will be looking in your booklet specifically at page 4. Remember, the objective is to review the various characteristics of a linear and quadratic functions. Please review page 1, 2, and 3, and then we'll get to page 4 today. All right, on page 4, we're now looking and finding a specific point that lies on this linear function. So why are we doing all this? Why are we first finding a slope? Then why are we finding a line to an equation? Then why are we graphing a line from an equation? Well, that's because all these lines are made up from lots of points put together. So when we do this, we can actually find specific points. Let's look at example 1. Here I have my equation negative 6x plus 2y equals 8. I want to find y when x equals 4. So that means I want to find the exact value. So I'm going to replace the letter x with the number 4 and then use my Algebra 1 skills to figure out what y is. So I now know negative 6 times 4 is negative 24 plus 2y equals 8. Now how do you solve for y? That's right, I'm going to add 24 to both sides. Now don't forget, 2y has a y in it, so you can't mess with that. So now I have 2y equals 32, and then I divide both sides by 2, and so I get y equals 16. So what does this mean? Well, this means this is an actual point on the line. The actual point comes from my x and my y values together. So I'm looking for the point 4, 16. Let's take a look at example 2. Now we're going to write it in what we call function notation, but it's still going to be the same thing. I have the equation f of x equals negative 4/3 x plus 4. I want you to find the actual point when f is f of 6. So that just means when x equals 6, I want to find the answer. So we write it as such. So f of 6 equals. So every time I see the letter x, I'm just going to replace it with the number 6. And then I'm going to actually find the answer. And you can actually put this in the graphing calculator. So here I've put it in my graphing calculator. And now all I have to do is hit enter. And the answer is at negative 4. So we write the answer as such. So it's going to look like this. F of 6 equals negative 4. Well, what does that really mean? Well, this is actually a point. This is the point 6, negative 4. Let me show you what that looks like on the graphing calculator. So on the graphing calculator, here is the actual equation that we gave you. When you hit enter, it shows you the linear function, the line. So now we asked you to find f of 6. So I'm going to go to the table, Control T, and I'm going to look here on the x value until I get to 6. Well, there you go. At point 6, I am at negative 4. So let's take a look at if that's really true. So looking at my graph, if I were to go over to 6, and then I go down, would I hit negative 4 on my blue line? And sure enough, I do. So this is why it's called function notation. You are looking for a specific point on the actual graph. Can you try example 3 on your own? Can you tell me where would you be if I wanted to find negative 3 on my graph? Hit pause to try it on your own. Hit play to check your work. So there's two ways of looking at this. So the first thing I did was I replaced the letter x with negative 3, typed it in my calculator, and my answer would be positive 8. So f of negative 3 is supposed to give me 8. So remember, what does that mean? It means this is an actual point. The actual point is at negative 3, 8. Let's look at my graph then. So here's my graphing calculator, and if I go to negative 3, I do get 8. So if I go over to negative 3, even though you can't see it right now, negative 3, and then I go up, I do hit 8. So there's two ways of doing this. You can actually do it by hand or looking at the graphing calculator. Now let's review and let's talk about the domain and the range. Do you remember what the difference is? That's right. The domain are all of your x values. The range is all of your y values. All right, so let's look at example 1. Can you write down all the domain values? I'll start you off. It will be x equals, and then you're going to list all the x values. All right, so did you put -1, 0, 1, 2, 3? What about the range? Range are your y values. So you're going to start out listing all of your y values. So this is easy if this is a discrete graph. Discrete graph means I'm going to give you all the points. But it is a little bit more difficult if I give you a continuous graph. Continuous means I'm going to connect all the dots and it's actually going to be a line. Do you remember how we found the domain and the range to a continuous? Alright, so domain are all the x values. Remember, this is where we drew the left side and the right side. But if you notice, if I try to crop this picture, there's arrows on both sides. So that means it's going to keep going to the left and it's going to keep going to the right. So do I actually have an answer? That's right, I do. It's going to be from -infinity to +infinity. You can also write it as all real numbers. That means it's all the numbers I've ever known. So you can write it both ways. You can also write it as the capital R as well. So let's talk about the range. So the range is what we go up and down with. So we're going to look at the bottom of the graph, which again, there's another arrow, which means I keep going down. And I'm going to look at the top of the graph. But again, I have another arrow, which means I keep going up. So how do I write this? I write it very similarly. -infinity, but this time it's a y in the middle, to +infinity. And again, if you would like to write all real numbers, you can also, or you can write the big R. Congratulations! We now know how to find each specific point and also to find the domain and the range of a linear function.
Hello, this is your instructional video over the star review of linear and quadratic functions. This will concentrate on page 5. And your objective is to review the various characteristics of linear and quadratic functions. So let's begin. This section would deal with system of equations, and a system of equations is two or more equations. So we could be dealing with 2, 3, or so on, as long as we have two or more equations. How do you graph a system of equations? Well, step 1, you need to change both equations to slope-intercept form. So we're going to change both equations to slope-intercept form. And slope-intercept form is y equals mx plus b. So that will be our first step in solving a system. Step 2 will be to graph both equations. So we need to graph both equations. And remember back from page 3, if you need to review that, we learned how to solve for y equals mx plus b, and we learned how to graph by using the slope and the y-intercept. So we're going to use the slope and y-intercept. And once you do that step, we will now find the solution for step 3. And remember, solution means various things depending on your topic. And our topic here is a system. So when we're talking about solution of a system, we need to remember that a solution is the point where the lines intersect. So in other words, on step 3, when we say find the solution, we're actually talking about finding the intersection of the lines. No matter how many lines we have, if we have 2 lines, 3 lines, we need to find where all of them intersect. Okay, so let's begin our example. I have a system here because I have 2 equations, negative x plus y equals negative 7, and x plus 4y equals negative 8. Our first step was to change this to slope-intercept form, to y equals. So I need to solve for y. So I'm going to start by cutting my page here in half, and I'm going to put one function, this one right here, on the left side. So I have negative x plus y equals negative 7. Then I'm going to write the second function right here on the right, because I need to solve for both of those and make sure that they are in y equals form. Okay, so I'm going to start by solving our orange line. I'm going to put my line down my equal sign so I can separate it and start solving. So I need to get y alone, so I need to add x. I can't add it to the negative 7, so I write it to the side of negative 7. Bring my y down, cancel out my negative and positive x, and I get y equals. I like to put my x in the front so it looks like y equals mx plus b form, minus 7. So I have y equals x minus 7. This is now in slope-intercept form. So I'm now going to move over to my green line and put that one in slope-intercept form. So again, I'm going to put my line down my equal sign and solve by subtracting x to both sides of the equation. These cancel. Okay, so my x and my negative x cancel. I'm left with 4y equals negative x minus 8. I'm putting my x in the front so it can be in slope-intercept form. I'm now going to get rid of that 4 by dividing everything by 4. 4y divided by 4 is y equals, I have a negative 1 right there at the top, so that's a negative 1 over 4x, and negative 8 over 4 is a negative 2. Okay, so that was our first step, was to put it in y equals form. Now that I've done that, I'm ready to start graphing them. And remember, we have to use our slope and our y-intercept to graph this. So I'm going to start by using identifying my slope and my y-intercept. So right here, that is my slope, my m, which in this case is a 1. And over here, negative 7 is my y-intercept, otherwise known as my b. You start with the y-intercept, so I'm going to plot negative 7 on the y-axis. 1, 2, 3, 4, 5, 6, 7, negative 7 down here. And now I'm going to use my slope, and my slope is rise 1 and run 1. We put that in a fraction, so I'm going to rise 1 and run 1 in the right direction. I'm going to continue that until I fill up my entire graph. Once I have that, I can connect these, and I have my first line. Now to graph my second line, let's take a look at that one. I have a slope of a negative 1 over 4, and my y-intercept is a negative 2. So that means I need to start at negative 2 on the y-axis. And because it's a negative 1 over 4, I'm going to go down 1 to the left, to the right 4, down 1 to the right 4. Since I can't go further anymore, I'm going to go up 1 to the left 4, 1, 2, 3, 4, and continue that until I fill up my entire graph. Now that I've done that, I'm going to connect these and get my second equation. There we go. So that was our second step. Our last step was to find the solution. And remember that the solution of a system is the point where they intersect. So I'm going to write solution here. That was the whole basis of this, is to find the solution. And I'm looking for where they intersect. And they intersect right here, which is x first for your ordered pair, x and then y. So I have 1, 2, 3, 4. And down 1, 2, 3, so that's a -3. So my solution would be 4, -3. Alright, have a good day. Hello, this is your instructional video for the STAR review of linear and quadratic functions. Remember that your objective is to review the various characteristics of linear and quadratic functions, and this video will concentrate on page 6. Page 6 will deal with linear inequalities. So let's begin by talking about the definition of a linear inequality. A linear inequality is the relation between two expressions that are not equal. So, since these are not equal, we have to use something besides an equal sign. So our inequality signs consist of our less than sign, our greater than sign, then we have our less than or equal to because it has the line underneath it, and greater than or equal to because it has the line underneath it. So now that we have our inequality signs, let's talk about how do we graph an inequality. So let's start with step 1, and step 1 Once we have it graphed, we then need to determine if we have a dashed line. So we need to see if the line is dashed or solid. Dashed or solid. And if you should shade above or below the line. Okay, so let's review what we would need to look at to determine where we shade. So, first of all, if it's a line, if it's a dashed or solid line, dashed means not equal. So if it's not equal, you have a dashed line, and the inequalities that are not equal are the less than and the greater than signs, because if you notice, they don't have that line, so they're not equal. If you are a solid line, that means that you are equal, and then you would use the ones that have the less than or equal to sign and the greater than or equal to sign. Now, let's think about, are we going to shade above or below the line? So, above means that we are greater, so we're going to use the greater than sign, or of course we can also have the greater than or equal to sign, and below is where you're going to use the less than or the less than or equal to sign. Okay, so let's begin our problem. We're going to graph this linear inequality. 4x minus y is less than 3. We're going to begin by, first step, putting it in y equals form, okay, or putting it in slope-intercept form. So I'm going to subtract 4x from both sides of the inequality, bring down this negative y, don't forget that that's a negative y, bring down the less than sign, And then I want x in front, so I'm going to put negative 4x in the front and then plus 3 in the back. I have a negative in front of this y here. I don't want to leave that there. I have to get rid of it. So that's a negative 1. So I'm going to divide by negative 1 to everything. And this is where we need to stop and think. I'm dividing by a negative. So this becomes a positive y. My sign flips. So now it becomes a greater than sign. And the negative 4 and a negative 1 is a positive 4x. 3 divided by negative 1 is minus 3. Okay, so this is going to be the function that I'll be graphing.
Gosh, Mom.
Okay, so a little note that we need to remember here about our signs is that when you multiply or divide by a negative number, the inequality flips. So that's what happened right here on our function is our inequality flipped because we divided by a negative 1. So now that we did that, let's begin by graphing this. So we're going to use our slope and our y-intercept. So we have a slope and our y-intercept. Our slope is right here, 4 over 1. And our y-intercept is negative 3. So we're going to start at negative 3 on the y-axis. And then we're going to use our slope, which is 4 over 1, to go up 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Until we fill up the entire graph. I'm also going to go down 4 over 1. In the right direction because this is a positive line. Now that I have my ordered pairs, I don't connect them just yet because remember the next thing I need to do is to determine what kind of line I'm going to have and if it's going to be shaded above or below. So I need to look at my sign, what I ended with. So I ended with a greater than sign. So if you look back at your notes, that means that this is going to be a dashed line because it doesn't have the equal sign underneath it. And it's going to be shaded above because it is greater. So now that I know it's a dashed line, I'm ready to go ahead and start dashing this. So I'm going to put dash through here all throughout and then put our arrows at the end to show that it's a continuous line. I'm going to now shade it. So I will shade everything above the line. And to determine where is above the line, I'm going to go to my y-intercept, which is right here, and I'm going to go on top of the y-intercept. So anything up here is going to be shaded. Anything above that line will be shaded. So we need to lightly shade that with our pencil. And this right here represents the solution of the inequality. Anything that is in that shaded area would be my solution. Okay? Have a good night. Make sure that you put a little note about the solution being the shaded area.